Hello. Okay. Hi everyone, I'm Josh. As Tim said, I happen to work at Google. This is absolutely nothing to do with this talk. I'm not representing them in any way. This is me and my hobby project. Hi. It's good to be here. I wanted to start this by asking how we got here, in a somewhat literal sense. I don't mean catching a tram or walking to the venue. I mean, we all sort of went to this website and picked up a ticket. And so what is a website? Well, to answer that question, we need to talk about this man, whom I don't really have a grudge against, but some people seem to. Sir Timothy John Berners-Lee, member of the Order of Merit, Knight Commander of the Most Excellent Order of the British Empire, Fellow of the Royal Society, Fellow of the Royal Academy of Engineering, Fellow of the Royal Society of Arts, and Fellow of the British Computer Society. And I think he did earn all those letters, but because he invented the web, lots of things happened as a result of that, such as frames, ad tech, the blink tag. Now, maybe we could blame him for that. I am just kidding, of course. I don't really want you to go out and headhunt him. And there are some things that I think Tim Berners-Lee does really well. For instance, his personal website has a very low web bloat score. So just to explain what this is, you take the amount of data you need to download from the website, and you compare it with the compressed image that you could generate from a screenshot of that web page after it's loaded. And as you can see, that his homepage is 163 kilobytes if it were an image, but only 8 kilobytes if downloaded as HTML. Just to compare, here's one of the examples on webbloatscore.com, and it says that Amazon has a score of 5.29. It downloads nearly 5 megabytes of content over nearly 350 requests. And that might not seem like a lot in the modern age, but if you're on, if your phone's dropped down to 3G, or you're in a country like Australia where the internet is just backwards, then you're going to have a fun time. Here are some other examples. Apple's pretty good. They're less than 1, which is great, but that's sort of a reflection of the fact that it's a somewhat image-heavy website. And just to pick on my own employer, the web result page for WebBloat is 600 kilobytes of content in HTML, CSS, and JavaScript, and so on. But if it were just an image of the top 10 list of hits, it would be 77 kilobytes, which is tiny. So we have Tim to thank for all that, and the reason I think his website's so good is because, well, he invented the web in 1991 when this album was released. On this computer, this is a Nextcube. This is, I believe, the first ever web server. It literally has a sticker that says, "Please do not power this down. It's running the web." He created the web in a time when there were less than 500,000 computers connected to the internet. And most people connected to the internet with something like this, a modem that talked over a phone line, which is kind of like a mobile phone call, but over a piece of wire. And it was really slow. It would take at least 45 minutes to download Amazon's web page with this modem. Just think about that. Now, I don't really want to judge Tim too harshly here, but one thing we can do is we can do some thought experiments to try and see if maybe Tim Berners-Lee had some hand in if things would have gone differently if he hadn't invented the web or something. So I thought I'd write some internet fan fiction, so to speak. So let's suppose he doesn't invent the web, he gets distracted with some other computer. He is in his work at CERN, and Gopher takes off. And this idea is clearly preposterous. It sort of reminded me of
Alan!
this meme.
Alan! Alan!
Gophers.
Alan! Al!
Alan was someone else,
Alan!
wasn't he? He did some
Alan!
small talk or
Alan!
something.
Alan! Alan! Alan!
You've all
Alan!
seen this, right? It's
Alan!
fun. It's 30
Alan!
seconds worth of fun.
Alan! 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 Al! Alan! 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 Alan!
Shout out to Alan in the
Alan.
audience. Hi.
Steve. Steve.
Steve! 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 Steve!
Steve.
Steve! Steve!
Steve. The answer is Steve. I don't think that Tim Berners-Lee would have given up on his web idea so quickly. I think that we need to go back a little bit further in time to figure out a scenario where Tim Berners-Lee might not have created the web as we know it. So suppose Steve, who left Apple in 1985, didn't go and then found Next. If Next didn't get founded, then the Next Cube wouldn't have been invented. So Tim Berners-Lee would have had to, I don't know, use a Sun workstation or something else that was equivalent at the time. And that would have been pretty cool. Like we would have had like Jurassic Park style web browsing. But that has some follow-on problems for us, because if Apple never acquires Next because it doesn't exist, they'd probably continue trying to develop Copeland OS and die, which means AUC never happens or never continues, and DevWorld never happens, and we all listen to music on our Zune. I don't like that scenario, so let's continue. Here's another attempt. Suppose Steve stayed at Apple. I consider this highly unlikely considering the personality clashes at the time, but as a result, let's suppose that Apple doesn't spin out its software division into a separate company, and Tim takes up a Macintosh instead of a Sun workstation or a Next Cube to create a web based on HyperCard. Yay! Well, that would be pretty cool, and maybe HyperCard would be released into version 3. But I think there would be similar problems there, because if Apple, again, if the web was based on HyperCard, there'd be an incentive to sort of softwareize a lot of the. HyperCard's kind of like a closed format, whereas the web we have today is kind of an open format where you've got text files, basically. So I sort of backwards foresaw that maybe a bunch of companies would try and fragment this early web, which is, yeah. If you just bear with me a moment, I'll try and resolve all this problem with my final attempt. Okay, suppose Steve leaves Apple, likely, and somehow convince Bill Atkinson, the creator of HyperCard, to join him at Next. Again, could have happened. And let's suppose that his getting caught up in Next delays the creation of HyperCard. And then it launches as part of Next. And then Tim uses his original computer to create the web, but uses some kind of open Next card software. And then everything's happy. Next enters the consumer market by purchasing Apple, which is sort of the reverse of what actually happened. But we get DevWorld, which is happy, joy time all around. But clearly none of this happened. So what am I to do? Well, I'm always going to ask, what if the web was based on HyperCard? And I'm an engineer, well, a software engineer, which is not a real engineer, but I think this still applies. Let's try and build it. Okay, so problems with this. HyperCard, last released in 1998, version 2.4.1. It's only got black and white graphics out of the box. Later versions had some basic color support, but you needed to bodge in some extensions for that. Only runs on old Macintoshes. You need an emulator of some kind. Here is the HyperCard stack, as you would, well, the software stack, not the stack of, anyway. The HyperCard documents live in HyperCard. HyperCard runs on the system software, which talks to a Macintosh ROM, which runs on the actual hardware, right? Here's an example stack. And the benefits here is most levels of this stack are pretty hackable. If you have an old Mac, you can hack the ROM by just ripping out the chip and replacing it with a modern replacement. You can hack the system software. It's just 68K machine code. You can hack HyperCard itself. And you can hack individual stacks by putting external commands in them. They're just resources that you can load with ResEdit. But It's a bit of a problem that not really anyone has these computers anymore. I have a few. I'm not giving any away. Not sorry about that. No regrets. But I have a solution, and I think you'll all be happy with it. Per my last 3 DevWorld talks, in which I sort of continue, this is the 4th talk in kind of a series. In most of these last 3 talks, I've mentioned emulators and how we can use them to run old system software and this sort of environment. And I'm pleased to announce that you all get an old Mac, sort of. We're going to use more layers in the stack to give you HyperCard. And so the basic idea is we'll insert an emulator, and that runs on your host operating system, and the emulator provides the fake Mac and everything above it. And as in previous talks, I've mentioned a bunch of these emulators before. You can look all these up in your own time. And a bit about how emulation works, right? Because this is somewhat fundamental technique these days in like just about everything we do. There's some kind of layer of emulation happening. You just don't see it most of the time. So if you're emulating a CPU, what that's giving you is basically a state machine, if you're familiar with the state machine programming pattern. It's just that the number of states is huge. And each time a real CPU marches along memory executing instructions one at a time, right? So one way you could implement that in an emulator is just to say, okay, I've got the instruction, whatever, a 16-bit number. I'm going to map that to one of 65,000 functions, and that function is going to implement whatever that instruction does. Similarly, RAM, you could emulate that with an array of bytes in memory, pretty simple. ROM is just a sequence of bytes that's somewhere in memory that you access. That's usually how it works. Similarly, the other bits of a computer can be emulated by some layer of indirection, which is what this is all really about, indirection. But there's a problem with all the classical emulators that you have to sort of download software, you have to get a ROM image somehow. You're supposed to get this by dumping a ROM from an actual Macintosh, which sort of, go back to step 1 and get a real Mac. And if you've got a real Mac, why would you run an emulator? You have to get the system software. It's freely available nowadays, but you have to find it. Okay, but this is kind of too many steps. Like, really, ideally, this should be like step 1, and then there's no step 2. Well, there's a solution for that, and that's add more layers to the stack. I love this XKCD. It's great. So in-browser emulation, and I mentioned this last year, but I thought, hey, that's really cool. I wonder if I can run that for myself. So I went and did. Here's how the stack looks for web-based emulation. So we have a fake Mac. It's running in an emulator that is compiled to WebAssembly, and which then runs in a JavaScript engine in a web browser on top of your computer. Okay. The development process is pretty straightforward, actually. So you take an existing emulator. In this case, a guy called James took one called PCE. It's written in C. And other than some compatibility things, so the traditional PCE emulator has outputs as graphics to using the SDL library. For Emscripten, you need to port that. So James did that. And then you basically compile it all into WebAssembly, and then you can serve it and it'll run. And here it is running again. I just stole his emulator. I didn't actually do any of the hard work of porting it. And you can play with it there. This emulator formed the basis of the Internet Archive emulators. So if you want to play around with random Mac software, you can do that there, and it'll fire up in the same system. But really, I thought, well, it would be nice if I could share my Mac with all of you. So I went and built the thing and uploaded it to my own website, and here it is, hypercardadventures.com. This fires up a System 7 disk image with HyperCard in it and a few other bits and bobs. You just go to that website, it'll download and run straight away. So, you all get a Mac. Some of the challenges with this approach are obviously browser supports. Not every browser supports it, but WebAssembly has been around for a couple of years now, and it does work on Safari on mobile. So check it out on your iPhone or your iPad. Persistent storage needs some kind of backing, like IndexedDB is a common solution for web browsers. So I just have to turn that on at some point. The disk images are kind of big. One solution, if you're hosting a website and you've got big content, is to compress it. Most web browsers will automatically ask, hey, I accept encoding gzip. And gzip works fairly well on hard disk images for some reason. They've got lots of empty space. The speed of the browser emulation seems a bit slower than a native emulation in an app. That's, I think, something that'll just solve itself over time. And I don't have sound working. James' friend has sound working in his emulator. I'm going to implement that at some point. For other stuff, you can always go to caniuse.com and figure out what browsers support what. Here's the page for WebAssembly. As you can see, it's basically all the major browsers and some of the mobile ones, larger mobile ones. Here's the code. You can get it from GitHub. Modifications that I've done to it, because I wouldn't just fork it if I didn't have a fairly good reason. I wanted to build it as an ES6 module rather than a Node module, because I kind of had problems with some of the Node dependencies. I don't really like Node. I don't really understand it. That's probably why I don't like it. I wanted to expose extra functions. So one of the things you can do in my emulator that you can't do in James's, or at least maybe, I haven't been to his website recently, so maybe he's added it. But you can't just dynamically add your own disk images. That's something I wanted to be able to do, is to be able to give everyone the opportunity to go, oh, I have this old Mac software, I want to run it. I'll just upload it into the JavaScript environment. It's not actually uploading it to any server. It's just local. But it allows you to bring your own software and files. And also to be able to then save them back. Yeah, some challenges in doing that were moving away from Node.js, figuring out how to hook various bits and bobs, dealing with file sizes, as I mentioned. And have a bunch of future work, which is actually sort of the whole premise of this talk was, how do we make a web based on HyperCard? Well, that's all the rest of the work, pretty much. Now that there's an emulator running in the browser, I could start hooking different functions in it to talk to JavaScript. And I'll show a little bit of code in just a second of sort of how this works in Emscripten. But basically, you can, from your C that you compile into WebAssembly, you can put macros that then break out into JavaScript and call JavaScript functions from inside your C that's running in. Anyway, breaking the layers. So once I have that, I'm planning on connecting the fake serial ports together so that you can have a LAN party, basically. Except it's not LAN, it's on the internet. And with that, it should be pretty simple to add the ability to grab HyperCard stacks from other people's machines and then keep browsing between them. So you can just go, oh, I'm on one HyperCard stack, click, 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 and now I'm on someone else's, click, 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 oh, now I'm on a third one. Some stuff that I want to add now that I've been to DevWorld. AR, it seems pretty cool, so. Should I migrate to SwiftUI? You decide. So let's talk about the code. I'm going to just pull this out for a second. Here's some code from the emulator. Now this, most of this is the open source PCE project. Here is a file in the Mac Plus emulator part, which handles messages. And the point of the messages here are PCE has a window which has got the screen of the emulated Mac, but it's also got a console. And you can type commands into the console to make it do stuff like insert a disk, eject a disk. This functionality wasn't exposed in James' friend's port, but I really wanted to be able to use the same functionality. So here is where I defined paperclip, and that's just force disk eject, right? And that's what just the explanation there. If you have an old Mac, there's a little pinhole next to the disk drive, and if the Mac freezes up and you want your disk back, you straighten out a paper clip and you stick it in the hole, and then that forces the disk to eject. Right, that's why it's called paperclip. Now, I also needed to tell the user interface that wraps the emulator the disk has been ejected. So here we have the emasm macro, which wraps some JavaScript that I run. On disk eject is just a function that I defined in the module. So basically, anyone who uses the module can go, oh, I need to be told when the disk is ejected. Here's a function. Run that when the emulator has ejected a disk. Similarly, there's inserting a disk and saving a disk back to a file. Inserting a disk a little bit more complicated because it's got to compose a file name out of, well, a disk index colon file name. So I have to massage some strings, really basic sort of C style. But and then once that's done, it's pretty much just a matter of calling the function. Similar. And about emulator technology, so PC is designed to be an emulator for multiple architectures. I've ripped out most of the other architectures than Mac Plus, so that's why it looks a bit different. But here's the CPU emulator. So a Mac Plus consists of like the CPU and a bunch of other chips as well. But just on the topic of the CPU, here is a, oh, where is the header file? It's a bunch of helper macros, but this is the struct here, e68000_s, and that has the emulated state of the CPU in it. So we have, other than, like, ignore these function pointers, but here's basically where it begins. So 68K has 8 D registers, 8 A registers, a program counter, some helper stuff in the background, whether it's in supervisor mode or not, and so on and so forth. And then once you actually have that struct ready, this file contains something like 1,000 functions which basically implement each single instruction. And it's all sort of complicated and very well done. I have great admiration for Hamper Hug, who wrote the PC emulator in the first place, for doing all this work. The other thing I wanted to show was just how easy it is to use Emscripten. So if I just, oh, hang on, maximize that one, haven't I? Here's iTerm. I'll just blow that up for you. I won't go through installing Emscripten, don't really have the time, but I've sourced the environment so it's all ready to go. So I've got emcc. Oh, that's not how you use it. But anyway, it's just a drop-in replacement for the Clang C compiler with an LLVM backend. It still uses LLVM, but instead of compiling to x86 assembler, it compiles to WebAssembly. So what you can do is I can go hello dev world as an example. I can create a really simple file. It's going to be just going to take some shortcuts here. And then when you want to compile it, Emscripten lets you do this. So I want to say hello.html. And what it's doing there is it builds a wrapper HTML file in addition to the WebAssembly and also a JavaScript version of that code. So when you want to actually run it, you can go emrun. Actually, I'll just look at my and if I just drag that over. Here's hello.html in that folder that it ran, and there's the console that it printed to. So really simple to get into, and Emscripten provides you like this little sandbox environment for trying stuff out. But it lets you can do much more complicated things, obviously. There's a lot of ... in between that and running an emulator. But Okay, what else can you do with WebAssembly? Because it's an LLV and backend, you can compile other language to it. Unfortunately, Swift isn't ready yet. It does some complicated things that main is not entirely compatible with how WebAssembly works. Other compilers target it, like Go. It's a stack-based virtual machine, so you can actually host it in other environments than just the web browser. There's an initiative called WebAssembly System Interface, which sort of does a kind of a node thing. Cloud functions are some serverless thing. I hear Cloudflare is doing something with WebAssembly. Other things you might like to do with an emulator in a browser, though, is bundle it into an app with Electron. And here's an example of something someone did with Windows 95 in an emulator, which is an Electron app. You can download it from there, so you can get your Minesweeper fix that way. Okay, thank you for having me.